Okay, having a look at some graphing of exponentials in this little video today. So I'm going to run through a couple of the basics, and then this is kind of a lead in to getting into some log laws. So we're just going to work our way up to that. So there'll be a few videos all in sequence for this topic. So graphs of exponentials. We've got two different pictures that it can look like for our y equals a to the power of x. So whenever you've got a constant value there, so 2 to the power of x, 3 to the power of x, etc. Now, if your a is greater than 1, this is the shape it's going to look like. So it's going to come down this way, or you say going up there. But over here, we're getting closer and closer and closer to that x-axis, but we don't cut through. So we would call our x-axis the asymptote there, because it's going to keep approaching it but never cut through it. And it also always cuts at 1, because if you think about it, this is when our x is equal to 0. Anything to the power of 0 is going to equal to 1. So that's why we know for those cases where we have this format, it's always going to cut at 1, unless you have a number in front here that you're multiplying by. If your a is between 0 and 1, you've got a decreasing function there. So rather than increasing, you've got your decreasing. But again, it's going to cut at 1 because we've still got the a to the power of x, and anything to the power of 0 is 1. Now, some of the types of questions you might see might be involving graphing them on your calculator. So we've got a little example here, y equals 2 to the power of x. I'm going to pop that into my calculator here, clear what I've got. I've got my 2. Now, if you're not sure how to put the power there, we're using a little up arrow, and then we're using our x up the top here. When we graph it, we're just going to check how that fits on the window. Now, I was graphing something with quite a number of x values here, so I'm going to just change my window so I can see that a bit clearer. So you can see that I went up to a maximum of 50 there for my x. I'm just going to change that to 10, just so I can see a different perspective on my graph. So as you can see, here's my line there. It's increasing as I would have expected because it is at my a is greater than 1. I can see that it cuts through at 1 and it's getting closer and closer to the x-axis there. Now, I can then do some things once it's in my calculator. So one of the questions is finding the value of y when x is equal to 2.1. So this is using our second trace on our calculator. It comes up here with calculate. We're going to calculate a value. So I'll press 1 and I want to know when x is equal to 2.1. So I'll type that in there and I get a y value of 4.2870939. So a big decimal. The other option is to put my trace on and move that until I get it close to 2. But as you can see, you would have to zoom in and in and in to get exactly on 2 there. So using second trace 1 and putting in the value that you want is a quicker way to get to it. Now, the second part of it is that we want to find out what the x value is when y equals 9. So like I said, we could put our trace on and just keep moving along until we get to y equals 9. So you can see we're here at about 3.18, but that's not exactly 9, so we want to get a better way of finding that. So what we can do is we can put y equals 9 in. So we can put our y equals 9 into here as well, and then see where those two lines cross. So we've got our y equals 9 there. We can use our calculator function, second trace intersect, and see where those two lines are going to cross. They only cross once, so we can say enter, 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 and it comes up with the intersection of 3.1699, and we did see it was around that point when we put our trace on. So that's how we can use our calculator to do that. In my next video, I'm going to go into a bit of solving exponentials.